Around 150,000 tons of carbon fiber are produced every year. This material is as strong as steel, but with one major difference: it is much lighter. But how is this supermaterial made? To find out, we travel to China, the world's top producer, and step inside one of its factories to see how it is created. The history of carbon fiber dates back to 1860, when Sir Joseph Swan experimented with rudimentary fibers by carbonizing cellulose, although at the time they had no practical uses. The real breakthrough came in the 1950s, when the need for lighter and stronger materials led scientist Roger Bacon to create the first modern carbon fibers in 1958. However, in its early days, the high cost and limited performance of these fibers prevented their widespread use. The big shift came in the 1960s with the use of polyacrylonitrile, a process that made it possible to obtain fibers with a high crystalline carbon content. This drastically improved their mechanical and thermal properties, opening the door to their use in high-demand industries like aerospace. Companies like Boeing began incorporating it into airplane parts, taking advantage of its lightweight and strength to reduce fuel consumption and increase efficiency. Over time, the production of carbon fiber became more efficient and accessible, which allowed it to expand into other fields. Today, it is not only key in aircraft and electric vehicles, but also in cutting-edge medical equipment, ultralight prosthetics, and high-performance sports gear like bicycles and rackets. Its ability to withstand extreme temperatures and its durability have made it an essential material in modern technology. But how is carbon fiber actually made? Before we go into detail, did you know that the carbon fiber used in Formula One cars is so strong it can hold the weight of an elephant without breaking? This incredible strength is achieved thanks to a special material, the most common being something called PAN, which is ideal for creating strong and durable fibers. While other materials like rayon or pitch can also be used, they are not as effective as PAN, which is simply a polymer found in many things we use today. This base material is first turned into plastic fibers made up of thousands of extremely thin filaments, much thinner than a human hair. These filaments go through a chemical process that aligns their carbon atoms, a key step to ensure the final fiber is uniform and high quality. This is where spinning comes in, a process in which the material is carefully stretched to create continuous filaments that are then grouped into threads called tow. These threads not only make the material easier to handle, but also ensure the fibers are well distributed for the next stages. Once formed, the fibers are precisely aligned using specialized machinery. This step is crucial to guarantee that the fibers have maximum strength. Then they go through a heat treatment in an oxidation oven, where they are heated to around 200 degrees Celsius for a controlled period. This process causes the fibers to react with oxygen in the air, rearranging their atomic structure and giving them greater heat resistance. It is like hardening the fibers so they can endure extreme conditions in their final uses, whether in aircraft, high-end cars, or sports equipment. Carbon fiber is a super strong material, even stronger than steel, which means it can withstand enormous forces without breaking. Depending on how it is made, it can become so strong that it resists extreme pressure, almost as if it could carry the weight of something incredibly heavy without giving in. But to reach that level of strength, the fibers must go through a process called carbonization. In this process, the fibers, already black in color as we know them, are heated in a furnace without oxygen at extremely high temperatures, between 1000 and 2000 degrees Celsius. Imagine it like a kind of deep cleaning that removes everything that is not carbon, such as hydrogen and nitrogen, leaving behind only pure carbon. It is as if the material becomes fully purified. During this treatment, the remaining carbon atoms organize into a very compact structure and align along the length of the fiber. This alignment is what makes carbon fiber so strong and rigid. Think of it as a perfectly arranged chain, which gives it incredible resistance. These qualities make it ideal for situations where something lightweight but very strong is needed, like in airplanes or high-end cars. After carbonization, the fibers go through a chemical treatment that helps them bond better with other materials like resins. This step is essential to create composite products, ensuring that the carbon fiber integrates perfectly into the final parts, such as car components, aircraft parts, or other structures that need to be light but able to withstand great stress. In this process, the carbon fibers are submerged in a bath of water with electricity, which gives them a slight texture on the surface. This helps them better absorb the first layer of resin, which later combines with a thicker resin to create a stronger bond. At this point, the fibers already have the form of carbon fiber threads, which can be woven into fabric or used directly with resin to create specific shapes. When these fibers are soaked in resin and turned into sheets ready to be molded, they are called pre-preg. This material is widely used in industries like aerospace because it allows the creation of complex parts with great strength and precision. To protect the fibers and make them easier to handle, they are coated with a special layer called sizing. This coating not only prevents damage, but also includes chemicals that improve their compatibility with the resins that will be used later. The resin is prepared by mixing epoxy with hardeners and accelerators. Then, a machine applies this mixture in a thin layer over special paper that prevents sticking. At the same time, between 200 and 300 kilograms of carbon fiber are arranged into a structure called a web, which defines the size and thickness of the final sheets. These fibers, now soaked with resin, pass through hot rollers at high pressure, which ensures that the resin penetrates well into the fibers. After that, the sheets are cooled, and the liquid resin turns into a kind of gel. The protective paper is removed, and to prevent the sheets from sticking to each other when rolled, a layer of polyester film is applied. This ensures they are stored safely and are ready for use. The size and thickness of the fiber web determine how the final carbon fiber sheets will turn out. During the process, the resin-covered fibers pass through hot rollers at high pressure to make sure the resin is evenly absorbed, making the material stronger and more unified. Afterward, these sheets pass through cooling plates, where the liquid resin transforms into a gel. Once the material stabilizes, the protective paper is removed, and the upper part of the sheet is covered with a polyester film. This keeps the sheets from sticking together during storage. One of the biggest benefits of carbon fiber is that it is extremely lightweight. With a very low density and a weight 4 times less than steel, it remains just as strong or even stronger. This combination of lightness and strength makes it ideal for industries like aerospace, automotive, and sports equipment manufacturing, where reducing weight is key without sacrificing performance. In the final stage of production, the treated fibers are rolled into large spools to make storage and transport easier. These spools can be used directly or turned into fabrics or sheets, depending on what is needed. This careful packaging ensures that the fibers maintain their properties until they are used. Before becoming final products, a sample of carbon fiber goes through very strict quality tests. First, it is weighed, then it is treated with chemicals to remove the resin, and weighed again to ensure that the ratio between fiber and resin is correct. Strength tests are also carried out to make sure it can withstand extreme forces without breaking, guaranteeing the material is reliable. Once the carbon fiber meets all quality standards, it is combined with resins or plastics to create composite materials. These materials are molded or laminated to produce final products that are lightweight, strong, and durable, such as wind turbine blades, airplane parts, cars, bicycles, golf clubs, and even medical prosthetics. This process turns carbon fiber into an essential material for high-technology applications where exceptional performance is required. The result is a unique material that combines lightness and strength, designed to meet the highest standards across a wide range of industries, from aerospace to sports. Carbon fiber remains one of the most advanced and versatile innovations in modern science and technology. Carbon fiber is a truly amazing material. One of its most impressive qualities is that it does not deform with temperature changes, since it barely expands or contracts. This means it keeps its shape even in extreme heat or cold, making it ideal for uses where stability is crucial. This material is also highly resistant to corrosion, allowing it to withstand strong chemicals like acids and bases without damage. That makes it perfect for industrial settings or locations with harsh conditions. But that is not all. Carbon fiber is incredibly stable under heat. In an environment without oxygen, It can withstand temperatures above 3000 degrees Celsius without losing its properties. That is why it is a key material in industries like aerospace or energy systems, where materials are required to endure the impossible. And this is the entire process behind the production of carbon fibre. What do you think about it? Let me know in the comments. If you enjoyed the video, make sure to hit the like button and subscribe to the channel so you do not miss our next video.